There are many documented cases of laboratory personnel contracting diseases due to their work with infectious agents. Approximately 80% of these cases are assumed to be primarily related to the creation of bioaerosols in the lab. Aerosols are defined as colloidal liquid and solid particles suspended in a gas, usually air. A bioaerosol is a collection of airborne biological particles with sizes ranging from 0.5 to 30 micron. Particles with a diameter of 5 microns or less can remain airborne for a long period of time, spread wide distances, and are easily inhaled. Larger particles settle rapidly and can contaminate skin, equipment, other surfaces, and ventilation systems. When performing work with infectious agents, appropriate measures must be taken to protect workers and the environment. The use of biological safety cabinets and respirators by all persons present in the same room can provide protection, but only when they are used correctly and are accompanied by standard microbiological procedures and precautionary practices. This video describes common aerosol-producing activities like vortexing, centrifuging, pipetting, pouring liquid, removing air from a syringe, and safe work practices to protect workers from aerosols. Therefore, leaks or escape of aerosols were mimicked using fluorescein as an indicator added to water while performing the procedure. Presence of fluorescent splashes was then seen on surfaces by using an ultraviolet lamp. In this movie, aerosols could not be clearly visualized. Therefore, whenever splashes are seen, one should always keep in mind that aerosols are generated as well. We will now show how vortexing an open Eppendorf tube generates an aerosol, leading to the spread of contamination. As you can see, during the vortexing, a considerable amount of fluorescein ends up on the glove. The contamination can be easily transferred to any object touched by this gloved hand that is contaminated. Therefore, when vortexing tubes, always remember to use tightly capped tubes. In addition, it is important to remember that droplets can be present in the lid, which may easily be released when the tube is opened. The importance of vortexing closed vessels is also demonstrated here with an open falcon tube. Mark the large amount of fluid escaping from the tube while vortexing. This cannot happen with a closed falcon. Remember, however, that droplets can be present on the lid. Using open tubes, we give an example of what can go wrong in a centrifuge when tubes are not properly closed. Shortly after starting the centrifuge, a considerable amount of fluorescein is ejected from the tubes. This can be seen in more detail here. The result is a considerable amount of contamination on the lid. Pipetting can also be a source of aerosols, as demonstrated in the next clip. Pipetting fast above the Eppendorf tube results in splashes on the edge of the tube as well as on the gloves. It is therefore better not to blow out the liquid, but to gently release the liquid while touching the inner surface of the receiving tube or other vessel. When pipetting large volumes, aerosols can be generated when trying to blow out the last drop out of the pipette, as demonstrated by the two following examples. As you can see, aerosols and splashes are generated, which can end up on the bench, your gloves, or any other surface. Therefore, always drain a pipette with its tip against the inner wall of the receiving vessel and never forcibly expel any hazardous material from a pipette. Pouring liquid from heights is another activity which can generate aerosols. Pouring from great heights produces a large amount of aerosols and splashes. It is better to gently pour the liquid into the vessel, trying not to make any sudden movements. It is important to minimize air bubbles when filling a syringe or to cover the tip of the needle with a tissue moistened with disinfectant. Otherwise, the following might happen when you try to remove the excess of air out of the syringe. As a final example, we will show the consequences of a spill. A small plate containing liquid is accidentally pushed off the bench. Splashes not only end up on the floor, but also on surrounding surfaces and materials such as cupboards. As you can see, the splashes are widely spread, indicating the importance of setting a wide perimeter when cleaning up spills.